Hey guys, in this section we're really going to be looking at graphing those quadratic equations that we started looking at last time. You're going to need to know that information, so if you have not figured out these first two things that you see here, finding the axis of symmetry and finding the vertex, these are what I talked about in that section 1 video, so do that first because you have to have that done in order to finish the rest of this. Okay, so when we're graphing a quadratic equation, sometimes in the last lesson we just kind of sketched them generally to see what they look like, but not all of them will look that and follow that exact curve. So now we want to take that next step and find the exact curve. So the steps we'll take in order to do that is first we'll find that axis of symmetry, and let's just write it down what our formula was x equals negative b over 2a was the formula for finding that axis of symmetry. So then we're going to find the vertex. And now let me show you the fancy way to write that out, because I remember when we took that x that we found for the axis of symmetry and put it back into the equation, we found the y for the vertex. So what that looks like in function notation is I have an f of negative b over 2a. That just means I take whatever I found for my axis of symmetry, I plug it into the equation wherever there's an x, and I solve for that. Okay, so then that third step I do is I put the vertex in the middle row of a table, and then I fill in a table. I pick some numbers that are smaller and I pick some numbers that are bigger, both, and then I plot those points and connect them. So let's look at some examples together, and then you'll have plenty of time and plenty of examples to work through on your own. Okay, so again, like I said, sometimes when I convert to Word documents to write on, it doesn't come through very nicely. So you'll see that here, that my graphs look a little bit different than yours just because it didn't come across nicely. So this first example was y equals x squared. Okay, so first step, remember, we always put it into standard form, our largest exponent first, which in this case it is. So then I can find my axis of symmetry. So I know that my axis of symmetry is x equals negative b over 2a. Well, my b is 0, so I have 0 over 2 times 1, which is 0. So my axis of symmetry is x equals 0. To find the vertex, I plug that back in to my original equation, so I'd get 0 squared. So my vertex here is at 0, 0. So I'm going to go ahead and put that in the very middle of my chart. And then we can pick some values that are smaller and pick some values that are larger. So I'm going to go ahead and just pick negative 1 and negative 2 and 1 and 2. So then I pick those values, any values I want. I plug them back into my original equation, and then I can solve for my y's. So if I do that, I end up with 4, 1, 1, 4. Well, now I have enough information that I can actually plot these and graph them. So now I'm just going to plot those points. And I had a 0, 0, 1, 1, 2, 4, and I had a negative 1, 1, and a negative 2, 4. So now you'll see I have kind of the curve that I need to just trace and graph. Okay, so that's what that one's going to look like. So I want to come back up here and look at this domain and range because these are really important pieces too. So we want to recall that the domain of our function is all possible x values. So when I'm looking at quadratics, it doesn't matter if my a value is positive or negative. My domain for quadratics is always going to be all real numbers. And we can write it like that. That's just the symbol for all real numbers. So then the range. The range is all possible y values. So based on this graph, and we'll look at some transformations in the coming unit so you can see it easier, but from this graph I see I don't have any of my graph down below the x-axis. It's only going this way. So my range is going to be y is greater than or equal to 0. Because once I hit that 0 point, that is where I start to see my graph. Okay, so let's look at another example together. I'm trying to find a good one. This one will actually work. Okay, so we are going, yeah, this one will work. So actually it did come through. You see, here's my equation. Yours looks differently. Yours looks a lot cleaner. So first step, we want to look and make sure that it's written in standard form, which it is. So I've got x squared plus 2x minus 1. So I'm going to first find my axis of symmetry. So x equals negative b over 2a. So a negative b, which is 2, over 2 times a is 1. So that gives me an x value, an axis of symmetry of x equals 1. Okay. Negative 1. because I almost lost my negative sign right there. So don't lose your negatives like I do sometimes. Okay, so I've got that -1. So now to find the vertex, I take this value and I plug it back into my equation. So I would have a -1 squared plus 2 times a -1 minus 1. 1 times 1 is 1, minus 1 minus 1. So 1 minus 1 is 0, minus 1 is there is our vertex. So my vertex is -1, -1. So that point goes into the center row, the middle row. So then from there I pick 2 points, 2 x values that are smaller and 2 that are bigger. So I'm going to go ahead and pick just the next ones. So -2 and -3, and then 0 and 1. So when I plug those x values into my equation, I will get the y values of 2, whoa. I feel like I did something wrong looking at this. 1 minus. Oh, that's the part right there. I did do something wrong. Because 2 times a -1 is a -2. So 1 minus 2 gives me a -1, minus another one is a -2. So let's go ahead and erase this, because sometimes screw-ups happen, and that's okay. So this ends up being -2. That looks better. So now I'm back to putting my x values into my calculator. And you will notice that when you do this, you will end up with a symmetrical value, right? Your table you will see the symmetry in your table. So let's go ahead and graph that then. So I've got -1, -2, and then these are my other points that I can, whoops, right there, and that I can plot those. So again, you'll see my a value is positive, so it's going to open up and look like that. So now you'll see you've got several other examples to work through, and take your time, because when you don't, you screw up like I do. Okay, so you're going to work through these, and then you have this other sheet, excuse me, it's killing me today. You've got this sheet where you're going to analyze some of these quadratic graphs. So I want you to actually go ahead and do that and answer these questions. Just kind of test yourself on this and see how you're doing before you jump into the homework for this section. Okay, looking back at some of these words, is this a maximum or a minimum? How do I find the domain and range? Okay, so speaking of the domain and range, let's go back up to that example we just did, this one. Okay, so again, we said that the domain for all quadratics is going to be all real numbers. Okay, so my range, you can see that the lowest point that I ever reach in my graph and in my table is that -2, and my graph goes up from there. So it's going to be y is greater than or equal to -2. There will be lots of instances where this will not be a greater than symbol, where y will be less than. So if my a value is negative and that curve opens down, it'll be a less than. So I want you to kind of take what you've learned, and I'm going to post the answers to these examples so that you have some to look at, and just work through them and see if you can graph your own quadratics.